Hello everyone, come on, take your seats and enjoy my ride for today. My name is Mario Bodemann and I welcome you to this talk about PCBs, which means printed circuit boards, just so that we all know. Let's start story time by starting the story. Start of this year, as we all do, I did a New Year's resolution, and this time I found, okay, I'm gonna do it, you know? My New Year's resolution was, I wanna learn something completely new, which is like, how do I build my own hardware? Well, what's the way, what are the options, how can I program it, what do I need to consider? So, and in order to not just like have this random idea, I also had the idea, maybe we can evaluate somebody who decided to do things and give them something in their hand. And she's also in the audience, find her later to ask what this means. I wanted to make a die. So I wanted to make like something you can take for role-playing games or whatever, print it out, have LEDs on it because we all like LEDs, and control it through your Android phone. Not necessarily for cheating, but you know. So this is how the whole story started. What do you need when you want to do something with hardware, right? You need those things. I hope they're kind of visible also in the back. It's a microchip. You need, obviously, LEDs. You need those little things called resistors, because we know resistors are futile. And you need a button so that you have interaction also when you are just like connecting it to a non-smart device. You still want to have something happening there. Let's talk about this thing that looks like the brain, because actually it is the brain. I decided to go with the Xiao, which is a USB-C powered microchip, right? So like I plug it in, it does the thing. It runs with 48 megahertz, has 11 pins, so like 11 things I can send electrons through, and as you can tell by me speaking about this one, I know nothing about electronics. So this is my understanding of it, and it was kind of cheap, so it worked. So I bought this one, and then I thought like, okay, now I have a brain, or I don't, but at least I have a brain in my hand that I can program. What do I do with it? Well, I read a bit, and then I heard about breadboard. As a German, I obviously thought first about food, but it turns out it's actually an electronic thing that you can plug in cables, the brain, LEDs, rearrange it, use cables to it, it looks like this on the, as you're seeing it on the image. So the nice thing there is like all the horizontal lines between the holes are connected. So like if I pin in one LED on one of the horizontal lines, I can have a cable going to the microchip and therefore have a cable connection. Interestingly, here is like this allows me to do things fast, right? So like if I don't know what I'm doing, like I can just do it again with this thing, right? I just like replug the cable. But sadly, like this looks very weird if I want to put it into a final product, right? Like if I want to give it to someone sitting in the audience, then this is actually like probably nice to look at, but not necessarily what I want to like be proud of and handing it out and around. So we are going a bit closer to the level of PCBs by going to the perf boards. So this is like just a board with holes in it and like say some metal on top, where I can be solidifying my idea even more, right? So the idea is I have the breadboard, I find out how the cables go, I find out where the LEDs and the resistors are, and now I want to just shrink the size a bit more. I would use this perf board, put in the LEDs, connect them with another cables, but this is a permanent solution, right? So unless I'm good at soldering, you probably know where this is going. I'm not good at soldering, so like I cannot desolder this one, so this is for me the permanent solution. It's smaller. You see it also blinking on my chest, but it's still kind of weird. I still don't want to give this one out, right? But the next step to make it even more solid would be the so-called PCB, a printed circuit board. So what is this? It's this green thing we have seen before, right? It gives me the flexibility to have it in different sizes. I can even decide where things go, right? And let's just go a bit further with like which software did I use for this one. I used EasyEDA. Why? Because it was something I found on the internet. If there are other options available, let's talk about it afterwards. But this is running completely in the browser, right? It looks like in a vector editor program, like Inkscape or whatever you guys would like to use. But it's actually designing the board, right? So like I can put a cable going from the LED to the pin. I can design which level, because there are apparently different levels on PCBs, how they connect to each other, and everything is in an environment I understand. Plus I can import SVGs and use our favorite Andy as the design, like as the shape of the circuit board. And what, again, also is very nice there is that EasyEDA comes with a library. And this library gives me the ability to see what's actually out there, like what kind of tools and devices can I use to put onto the PCB. OK, now let's assume we have designed the thing we want to do, right? What would be the next step? It's great to see it in place, but EasyEDA also can like then show it to me in 3D. Right? Like coming from a computer graphics background, 3D is always amazing, so that's why I had to put this one here and let the animation stop exactly at this point in time so that you can see nothing, and that's all intentional. But the idea here is that I would be able to see, is this something which I would expect? Like, do I see the LEDs at the right point? Is the red LED where I want them to be, and do the buttons look right? So this was a great tool that also EasyEDA offers. Another thing EasyEDA offers is the connection to JLCPCB, I think. Sorry, words are hard. So this is an online provider that helps me get the design into an actual physical product, right? So like they take the design specs I gave them through EasyEDA, then, sorry for the layman's term, put it into the printer, print the boards, like put the lines, the cable connections where they need to be, and all of this comes out of the design from EasyEDA. The nice thing about it is also not only cutting and drilling of holes is involved, but they can also place parts, right? So like if I want to be very solid about things, I can tell them, please put an LED where it needs to be. And the connection is just nice. So like I design something on EasyEDA, then tell them, please export it to JLPCB, and then weeks later, I have to say, I can have this thing in my hand. You know, and this is just one of the greatest moments when you're like just having something in your head, you're designing it for weeks at a time, and then weeks later after shipping, you can see this is the thing I had in mind, and it might even work, which is even better, right? But you also saw, like, I had different like designs of the actual Android board, right? So, like, I started with the one on top that uses so-called SMD devices, like surface-mounted devices. These were the things I was talking about in the GLPCB section, where I can tell GLPCB, please put an LED there. This is a nice thing if you know what you're doing. Right? Because I have no tools at home who help me changing the design afterwards, right? So like usually you would take the SMDs, heat them up, turn them around. If you happen to place the LEDs the wrong way, you know, as I did, yeah, so like something was wrong with the first iteration, so I had a second one. There was also nothing really good working there, so I came up with the third one, and this is actually using the through-hole design. And the through-hole design is, like the name says, I have no surface-mounted devices on it. I only have told JLPCB to print holes, and then I solder something on there. Because if I happen to solder an LED the wrong way, well, I just like heat up the pins, turn it around, and try again. So like also therefore, it's good for the starter to like design something for the through-hole design. And once you're solid, you understand what you're doing, maybe you can go for the SMDs. So yeah, I just wanted to say, this is how you can get your actual hardware in. And I think we are here at a software company, so obviously let's go for software. But what is software on a hardware? Well, it's like kind of soft and kind of hard, so we call it firmware. The question here is how did I then design the brain to do the thing I wanted to do? I decided for taking the language Python for programming this brain because for me the iteration was way easier. So there are alternatives between using CircuitPython and Arduino. Arduino is compiled. I need to then upload it to the thing I want to change. With CircuitPython, it is just a mass media device. So I can plug it into anything that can read FAT16 or whatever exFAT format, change the code directly on the thing, save it, it uploads it, it updates it, and my new code is running immediately without compiling, without null pointer exceptions, I hope. And it just also helped me here iterating fastly. The problem is it's not fast, right? So the execution always needs to interpret it, right? With Arduino, I would be compiling it. I have a binary, the binary runs. With Python, I have a Python interpreter in between. So if you want to have LEDs always changing and always the right way, you might run into some speed problems, and I can show you the speed problems then later on to just see okay, if you want to do something that runs fast, maybe thinking about CircuitPython is an idea. But if you just want to iterate fast, which is my style, CircuitPython is a bliss. Because I was good able to just plug it into my phone, have a FAT reader on it, and then change the thing running on CircuitPython on my phone, which is awesome. Just a quick primer on Python here, and what was the first firmware we are building. Surprisingly enough, it's Hello World. Since we don't really have a display, if we only have a chip, the Xiao comes with one LED. So what we are doing is we're taking this LED and make it blink. Who doesn't like blinking LEDs? For Python, for the Python code, you need to import several libraries as you do, right? So you have the time library that gives you some delays. You have the board library, and this board actually is the CircuitPython specifics. The board represents the actual CPU you're programming, right? So it contains things like what pins do I have, or what other offers I have with the actual hardware I'm using it on. But also together with the board comes the digital I/O parts, where I can, in this case, define the variable A that stands for one pin. And then once I have this variable A, I can also say, is this sending electrons out or getting electrons in? Again, sorry for my software understanding there on hardware. So output would be sending out electrons. Once we have the variable A defined, we can make it blink by having an endless loop that sets the value to true, waits a bit, sets the value to false, waits a bit, and then repeats forever. So this is how you can make this beautiful LED blink, and this is all you need in order to make the die running. You just iterate on it, which variables, which pins, which ports you use, and this is the starting point for everything to come. Okay, so this is a firmware, right? This is great. I can plug it to my wall and have something blinking. I can use the buttons by changing the direction, whatever. But since we are here at the Android conference, how do we make a communication between this board and something else happen? So the idea here is, if we want to communicate, we usually use words. So I thought, well, let's start with a simple protocol that sends actually strings, that sends this string to the chip reads the string, and then does the thing accordingly. And then potentially you can also do the same thing the other way around, you could have the chip sending strings to whatever other device it's connected to, and then the device does the thing it needs. So once we have thought about hey, what kind of words do I want to use, the interesting question might be how do I tell CircuitPython what to use? Luckily, we can change the firmware to do exactly that. We just need to do one thing and remember one thing. CircuitPython comes by default with one thing called serial console. So this is a console that's automatically present so that you have some baseline of communication. But what you would communicate with is the actual Python interpreter running on the CircuitPython. So you can't use this one for your own ideas. But what you can do is like you can just ask CircuitPython to create yet another device that you can have under full control. Interesting there, you can only do it once, right? So like only at the startup of the microchip, you can tell it like, hey, what kind of interfaces do you want to give to the outside? And therefore, we need another way of saying it, because the CodePy file we saw before runs all the time. It doesn't only run once. For the running once part, we have the boot.py file that's only called at boot time. And at this boot time, we can say like, hey, please take the USB CDC module and tell it that I want the console to be enabled. It's the thing which essentially is the interpreter. But I also want to have the data serial device to be enabled. Important here is that if you set console to false, that you have some way of setting it to true again. Otherwise, you would have locked yourself out. So like, just as a marker, if you set at any time the console to false, think about a way how you can set it to true in order to like debug the app or do other things you need to do with it. Once you have the boot.py set up, also like finding out what the PC or the Android app sends is rather simple. You, again, on the on the CodePy file, you would include the CDC, and then in the third line ask the CDC, the data part, like the data serial console, just read the line that is currently present, right? And then once you have this line, you can convert it into UTF-8, and then you can check it in the line 4, 5, 6, and 7. Is this light on? Is this light off? And then do the things accordingly to whatever your protocol or you want to do with it. So like in this case, it like really boils down to string checking, and I think that's kind of neat. So now we have the Zhao side of things. Like we now can set up the CircuitPython chip to like receive things, but how do we send things? I start with Linux because that's the easiest part. In Linux, the CircuitPython board would appear actually with two devices. You would have the ACM1 device, which is the data part, and you have the ACM0 part, which is the console, the Python interpreter. So what you want to do is you want to send the string light on to def TTY ACM1. That's it. So like literally, it's that easy. macOS, it's similarly simple. The name is something with modem inside. I forgot, I don't use Mac, and you have no problems there either. And about Windows, this is what I remember from my Windows time. I think this is how you define an environment variable. I don't know, that's all I know there. If you want to do it on Windows, there are tutorials online. I can't repeat it here. So I already have teased a bit at this is the simple side of things. Guess how it is on Android? It's sadly not that easy, right? Because there is no TTY ACM0 or ACM1 device connected. So if you want to do it on Android, there is a way, and that's the good news, right? Let's discover the device, right? So how it goes usually on Linux, you ask the system service to give me the USB manager. Then you ask the manager, do you have a device that fits specific criteria? I just have to rant a bit, and I'm sorry for this one. There is a getter called device list. What would you expect that this device list gives you? It doesn't give you a list, it gives you obviously a map. It's a map from device name to device, because probably it's easier for you if you know what device name you're looking for, you just use the map instead of iterating through it. But sadly, you might still need to iterate through it because you might have specific devices in mind that you need to check the properties of the device. Speaking of checking the properties of the device, you have to find the device that has a USB interface, that has a USB endpoint, that has the USB direction out. You have to find the device that has the interface that respects all of the above settings in order to come to the right device. So right now I have the USB, the JAW connected to my phone, and I have like 7, 8 interfaces on this one device, and I have to find the right one in order to communicate with it. Also, like you would think, again, it's a list or a map, but it's not. You get the maximum amount of interfaces or endpoints, and then you can get one individually by ID. So you can't just iterate through lists. You have to be kind of doing it a bit backwards, but it's fine. It's just me ranting about code, I'm sorry. So yeah, once you have found the right device, you can actually connect to the device if you have the permissions. So you have the device, you ask the manager, please give me the permissions to this device, and in order to get permissions to the device, you know probably how this goes. You get the broadcast pending intent. You set the right intent filter in order to get the right properties back, and then you actually ask the USB manager to get the permission for this device and the pending intent you have defined. Assuming the user clicked yes, assuming they gave you the permissions, you can now start to actually connect to the device. So again, you ask your manager, please open the device we have found, then you get the connection. You can then create the string. You remember the light on. Please remember also the new line, because otherwise the serial communication doesn't end. And then you convert it into a byte array. And then once you have the byte array, you can use the previously connected connection by calling bulk transfer on it. With the data, obviously, you have to repeat the size, because the byte array doesn't contain its own size. You give it the endpoint, and then you give it also the timeout the Android device should be waiting maximum for the device to be answering with the number of successfully transferred bytes. And that's the way. That's the easy way I found. Please, if somebody knows a better one on Android how to communicate through a USB device, I'm here to hear it. But this is the way my devices are connected right now, and it kind of does the thing it should be. Just going through it once more in a quick succession, right? So like you get the USB manager, you get the device. In the device, you find out if you have the permissions. Once you have the permissions by sending the broadcast gets the right device back. You know, I just had it, but I just think it's so funny to see all of the steps, which is essentially an echo to a device. Anyway, you can actually start communicating with it. Yes, so some thinking, some hacking. Afterwards, we have some love and can talk about the beautiful things that you can do with the device. I actually have prepared a little video which starts in the middle somewhere and teases what is happening, but in a second it will wrap around and start from, this is the device, it does its thing, then we're going through the Jetpack Compose app, we are changing the lights we want to show, we hit send, we send something, and then you see hopefully that the lights are changing. If this was way too fast, and here comes the hook now, please find me somewhere in the conference today or tomorrow, and then I can show you this in person, how this works and what other things I needed to do in order to make this working. It's kind of funny, because also I still have some time, so another rant. I have a Pixel 3a with Android 12 on it, and it stopped working. I don't know why. If somebody knows. Yes. Yeah, also, since we're here on Android, right, so the sample codes I was showing here are quite interesting, but I was also thinking, how would I integrate it in a bigger app, right? So, what would be an architecture pattern to make it still kind of clean, right? So at first, it feels like a repository, but it sadly needs something like the Android context to send permissions and things. So it feels like you can't just abstract it onto a repository. You need to have somewhere in between, right? Because you need the device, all of the Android things you cannot abstract. And that makes also testing hard, right? So like obviously I can like show you how things are working here right now, but I cannot like have it in an automated test, right? So this, unless I mock everything, and we like always to mock all the things, but yeah, there is some things I would love to think about some more. But yeah, so like if you want to do it in architecture, like putting it not into the main activity is already a good start, like having an abstraction layer there, but sadly it doesn't quite fit into the repository pattern. So now we have this, right? So like we have created the hardware, we have created the firmware, we have created an Android app that talks to the firmware, that makes lights blink or not, and depending on if you want to or not, you can change the results of the die or whatever it's displaying. But what else can we do, right? What are alternatives on things we would be able to, like, essentially the world is our oyster, right? So like everything that has a hardware system we can use. So like for instance, there are chips that can talk ZigBee, which is one of the protocols used for your IKEA lamps if you have like a wireless remote or something. So like you could have a device that attaches to your Android phone, and you could control the ZigBee IKEA lamps just throughout this device. Or you could think about an IR camera, right, which we also don't usually have, right? So like you could build a camera PCB that also plugs into your Android phone, and then you just see infrared things without needing to spend like enough money for getting an actual phone that does also IR camera things. And probably there's also a way to have a D10 or a D12 or whatever kind of dice you want to have in an app or in an actually hardware setup. Like I said in the start, the world is your oyster. This is an example on how you can do things. Obviously, there are ways to improve, but and this is, I'm closing my talk a bit early because I know it's lunchtime. You know, we all want to go for lunch. So I thank my employer right now for Mobimeo for the time also to be speaking here today. If you want to get hired as an Android developer or a potential tech lead, please come to our booth. Otherwise, I say thank you. Also, find me at somewhere place here. I might have some PCB for you. Thanks.